Okay, so we're going to be reviewing vertical angles, linear paired, and corresponding. Let me do a little recap of what they are. Vertical angles. So I'm going to have my two parallel lines and a transversal. My vertical angles are going to be on the same corner, so on the top corner or the bottom corner, and they're going to be opposite from each other. So for example, this angle with this angle, right? They're on the same corner, but they're opposite from each other. The only thing that they shared is 1 point. That's what we call corresponding. That's what we call vertical. We're going to call this vertical. Vertical angle theorem says we let those two angles equal each other. Another one we're going to review is linear paired. Let me talk about my two parallel lines and the transversal. Now, the linear pair are going to be on the same corner as well, kind of like vertical was. They're going to be on the same corner, but in this case, they're going to share a side. So I could be talking about this angle with this angle. That's what we call linear paired. And for linear paired, I add the two angles, and they are equal to 180. So for vertical angle theorem, I let the two angles equal each other. For linear paired, I'm going to add the two angles, and it is equal to 180. And then we also cover corresponding this week. Now, corresponding, let me say we have the two parallel lines, and we have a transversal. For corresponding, let me label this corresponding. For corresponding, the two angles are going to be on the same side of the transversal, either the right side or the left side. They're going to be on the same side of the transversal. One of them is in between the parallel lines and the other one is not. But they're not linear paired. So I could say I could have this angle with this angle. So you notice how they're on the same side of the transversal, this case the right side. One of them is between the parallel lines, the other one is not. But they're not next to each other. Otherwise, I would call it linear paired. Now for corresponding, I'm going to let them equal each other. So just a little recap. For vertical angles or corresponding angles, I let the angles equal each other. For linear paired, I add the two angles and they are equal to 180. All right, so let's review real quick. Let's review a mix of the three rules. The instructions here are going to be solve for x. Now looking at question number 7. The two angles in this case are corresponding. They're on the same side of the transversal. One of them is inside, the other one's outside, but they're not next to each other, so they're corresponding. For corresponding, I'm going to let them equal each other. So I'm going to say 16x is equal to 80. In this case, let me divide both sides by 16. X in this case is 5. For the homework, don't type in x equals 5, just type in 5, just the number. Let's take a look at question number 8. In this case, I have an example of vertical angles. Now, vertical angles, I know I have to let them equal each other. So I'm just going to say 60 is equal to x plus 67. I only have an x on the right side, so let me move that 67. Let me move it to the left side as a minus 67. Right, I'm going to do opposite signs. So I have that negative 7 is equal to x. X is okay if it's negative. We can have a negative value for x. The angle overall is positive. If you think about it, negative 7 plus 67, the angle overall is positive, but it's okay if the value of x is negative. Now I don't have a number in front of the x other than 1, so I don't divide. Let's take a look at the question number 9. Here we have an example of linear pair. So the way I'm going to solve this, I'm going to add the two angles, x plus 126 plus x plus 62, and then I'm going to let them equal to 180. Let me separate my sides to the equal sign. Let me simplify the left a little. 1x plus 1x, that's going to give me 2x. 126 plus 62, that's going to give me 188. And this is equal to 180. Let me have the x by itself. So the 188, let me move it over as a minus 188. I'm going to do opposite sign. So I'm going to say the 2x is equal to negative 8. Let me divide by the number in front of the x. So let me divide by 2. X in this case is negative 4. Once again, on the homework, just type in negative 4. You don't have to type in x equals. Now for question number 10, this is an example of vertical. Right, they're on the same corner and they're opposite from each side. So vertical angles, I let them equal each other. So I'm just going to say that 61x is equal to 60x plus 2. I'm going to separate them through the equal sign. I'm going to move the smallest x. So 60x, I'm going to move it over as a minus 60x. So I have that 1x. Right, 61 minus 60 gave me 1. So 1x is equal to positive 2. Looking at question number 11, here I have an example of corresponding. So for corresponding angles, I let them equal each other. So x plus 63 is equal to 60. Let me separate my sides to the equal sign. The plus 63, I'm going to move it over as a minus 63. So I get that x is equal to negative 3. So x equals negative 3. Once again, on the homework, just type in negative 3. Lastly, let me take a look at number 12. Here I have an example of linear pair. For linear pair, I'm going to add the two angles. So I'm just going to go x plus 112 plus 75. And this is equal to 180. Let me separate my sides to the equal sign. When it comes to letters, I just have an x. 112 plus 75, I can simplify that. 112 plus 75, that gives me positive 187. And all this is equal to 180. The 187, let me move it over. Don't forget to switch the sign. Right, I switch the sign whenever I move something from one side of the equal sign to the other side. So in this case, I have x equals 180 minus 187 is equal to negative 7. So x equals negative 7. The homework for tomorrow, for Thursday, is going to be pretty much the same thing. And then we do have our quiz this Friday that is going to be covering these 3 new rules.